All right, page 2 of S7K. So probability of R is this, probability of S is this, and we know the union is 0.7. Are these independent? So to be independent, we know that the intersection of A and B is equal to the probability of A times the probability of B, right? Well, instead of A, we've got R, right? So we've got this probability is 0.4, this probability is 0.5, and that's going to get us the intersection. So 0.4 times 0.5 is equal to 0.20, right? So that's our probability of A intersection B, or R intersection S, right? Now, I'm going to color this orange. Okay. Now, the law of probability says that the R union S is the probability of R plus the probability of S minus the intersection, the probability of R intersection S, because we don't want to have the overlapping part counted twice. So let's see, and if this is equal to 0.7, then we know it's independent. If it was equal to something else, then we would say it's not independent. So let's see if this works. So I'm going to replace this here with 0.4. I'm going to replace this here with 0.5, and I'm going to replace this here with our independent value, which is 0.2. And let's see if we get 0.7. So probability of A, or probability of R, is 0.4. Probability of S is 0.5. And subtracting the intersection, which we calculated to be 0.2. So 0.4 plus 0.5 is 0.9, minus 0.2 is equal to 0.7. So since these are equal, we can say, therefore, whenever you see 3 dots, that means therefore. That means it's yes, independent. Okay. All right, let's do question 2 now. We know the probability of A is 2/5. Probability of B is 1/3. And we know that the union is equal to 1/2. Okay, so find the probability of the intersection. Okay, so we know the union, we know B, we know A. So now we want to find the intersection. So here's our formula right here. Right, the law of probability is equal to probability of the union equals probability of A plus probability of B minus the intersection. And we're trying to solve for the intersection. So, so we know probability of A union B equals probability of A plus probability of B minus the probability of the intersection of A and B. Okay, so, but we're trying to solve for this one here, right? We're trying to get this orange one, because we know the yellow one, we know the blue one, and we know the pink one. So what I'm going to do is I'm going to subtract the probability of A union B on both sides of the equation. And I'm going to add the probability of A intersection B on both sides of the equation, which that's going to make this cancel out, and this is going to make this cancel out, and so we end up with the probability of A intersection B equals the probability of A plus the probability of B minus the probability of A union B. You may want to hit pause and think about that for a second. Okay, so now we have everything we need to solve for our orange intersection. So we've got 2/5 plus 1/3 minus 1/2. Okay, so we need a common denominator, so we're going to have 12 over 30 plus 10 over 30 minus 15 over 30, and we combine that together and we get our probability of A intersection B is equal to 7 over 30. You may want to hit pause and rewind if you need help, extra time to think about this. Okay, let's do question II now. Okay, so we just solved for A intersection B. Okay, now II says the probability of B given A. Well, the probability of B given A is equal to the probability of B intersection A divided by the probability of A. Well, we have all this information, don't we? B intersection A, or A intersection B, we just found that out, right? And probability of B, or probability of A, we already know that. So let's substitute that in. So this is equal to 7 over 30 divided by 2/5. Now, we have a fraction divided by a fraction. So in middle school, you might remember that we can change the division to multiplication by multiplying by the reciprocal of the 2/5. So I'm going to have 7 over 30 times 5 over 2. So I took the reciprocal of the 2/5 and changed this division into multiplication. Okay, you may want to rewind and think about that for a second. And so now we end up with 35 over 60, or you can simplify it to 7 over 12. I will accept either answer. Okay, you may want to hit pause and think about this. Now let's do question III. And so we've got the probability of A given B. So what we're going to do is that's going to be the probability of the intersection of A and B divided by the probability of B, since we're given B. Okay, so we've got this value here, it's 1/3, and we've got this value here, it's 7 over 30. So here we go again. We've got 7 over 30 divided by 1/3, which is going to give me 7 over 30 times the reciprocal of 1/3, which is 3 over 1. And then we end up with, this is equal to 21 over 30, or we can simplify that to 7 over 10. I will accept either answer. Okay, question B says, are A and B independent? Okay, so you might remember on our first page of the warm-up, if A and B are independent, then it doesn't matter if it's A given B or A given not B. These values should be equal to A, because if they are independent, the occurrence of B happening or not happening doesn't affect the probability of B. So if independent, then the probability of A given B should be equal to the probability of A. But this A given B we know is 7/10, right? And we know the probability of A is 2/5. Are these equal? No, they are not equal. Therefore, it is not independent. And that is the answers for the second page of today's assignment.